So by previewing the dataset, since we cannot open it with Excel, I used M-Editor so it doesn't damage the file. So looking at the dataset, the format for the time and dates, it's just not correct. So in order to directly upload to BigQuery, we have to modify the format of the dates and time, and figuring out how to upload to Bigtable is quite confusing. I spent 2 or 3 days and still nothing worked for me, so I decided to write some Python codes to fix the format of the dates and times so I can directly upload to BigQuery and link to Data Studio for generating the reports. So in Python, first we create say we use a Jupyter notebook so we can preview the result. So what I'm gonna use is the pandas. So import pandas as PD, and we read the wait. Before that, let me close this, and I'm gonna copy the original file to my desktop. And while after that, I'm gonna save this. Say formatting CSV. I'm gonna save it to the desktop, so under the same path. So save, and what we're gonna do is create a data frame, and data frame is pd.read CSV. And since it's under the same path, I might want to use a different name. Let's rename. Yeah, don't worry about it. So original dataset .csv. Okay, and then we can see if this code actually works. So we run this code chunk. While using the head function for the data frame, you can preview the first 5 rows of the dataset. And the good thing about using pandas to create a data frame is it will automatically generate a new column for you without the header. The left top cell is empty. So it could be used as row key, and you can simply add column family to it. Alright, so it worked. This is the original dataset. So after that, we're gonna format the dates and times. So data frame start time assigned to pd.to datetime function. So assign back. I don't know, it is this column. Start time, and before we finish this code, we have to specify the original date and time format. for Python to recognize it. Otherwise, it's going to be treated as a string. So format equals a format sideways months slash day slash year space. So we can see here it's only like 12 hours. So %I stands for 12 hours clock and column, and %hours and %seconds. And at the very end, we can see like there's a like PM or like AM. And in Python, there's an operator called like %P stands for the PM and AM, which will help Python to determine whether it's the nighttime or the daytime. So this is for the start time, and we have to do another one for stop time. So change this stop time and stop time, and we run this code to see if something is wrong. Okay, so there's an error. Let's see. What is wrong here? PD to data. Value error. Month, day, year. Oh, here should be minutes, not hours. So wrong again. It takes some time because the file is actually like 5 gigabytes. It's too big. But for Python, it's still like very fast. Okay, so no error shows up. Means it's working. We're gonna like preview the column contents to see if it works. We're gonna see start time first. Alright, so this is the correct time format, days and time format for uploading to BigQuery, and we're gonna again preview the result of stop time. Alright, both worked. So after that, it means the data frame actually changed. So now we're gonna write the data frame into a new CSV file. So we do data frame.pd.to CSV. We give it a new name like formatted data CSV, and we have to supply the date format for Python so it doesn't confuse. Date format assigned to, which the format we want is year dash month dash day and space. and make it 24 hours. So as we can see here, after we run the pandas to daytime, it's already changed to like 24 hours clock based on the AM and PM. So hours, minutes, column, seconds. Alright, so we're gonna run this and it will export the data frame into this CSV under the same path. So we're gonna run that. No, something's wrong again. Oh, extra PD. So just data frame.to CSV. We can see here there's already a new file. We'll just wait for Python to write all the whole data frame into the CSV file. Less 20 million columns, 20 million rows. Okay. Okay, 3 minutes and 25 seconds, very fast. And after the writing operation is done, we have to give the new file a preview to see if it fits, if it's complete. And we open with M editor. We can see the file size here is like 5 gigabytes. It's actually bigger than the original file because using pandas, it will automatically generate a new column with like a sequential ID for you. But this cell left empty. So we can see the date and time here, the format is correct already, and no more PM and AM. Good. So close that. After that, we're gonna come to the buckets of Google Cloud Storage, and we upload the file into the buckets. Which one is it? Formatted data. Yeah, this one. So while it's uploading, let's see. See the newly generated CSV files 4.887 gigabytes. The original one is 4.77 gigabytes. So which means after writing to the data frame and output again, actually 0.1 gigabytes increased. So now we just have to wait for the upload to be done. And while we're uploading, I think I should come to BigQuery, refresh, close, and I'm gonna create a new dataset under the same project for the DB trips. So dataset ID, let's use the course code, data location. I will probably like choose the same location as my bucket because otherwise it will not work. Yeah, so US Central 1. US Central 1, I got it. So no table expiration. Alright, create dataset. And under this dataset, it's empty right now, no tables. So after we finish uploading the file, we're gonna create a table by linking it to the CSV file in the bucket. I might try upload the dataset to Bigtable again after this video because like linking the data from Bigtable to BigQuery is actually treated as external data sources, and it requires something like a table definition file, and you have to specify the the data types for each column because it doesn't auto detect the data from Bigtable. And I think by uploading CSV files, like import CSV files into Bigtable, it requires a CSV format with the first cell left empty. So it will be treated as row key, and the column family will be added to above the whole file to the top column, the top row. Alright, it's down. So we come back to BigQuery, and in this newly created database, we click create table and we choose Google Cloud Storage, and we pick the file we uploaded. File format CSV, yes. Table, I'll just call it David Trips. Native table, yes. Schema auto detect. We can modify this later if we need to. And advanced options, route if empty, yes. Number of errors allowed there, yes. Create a table. What is that? Why so fast? 4.56 gigabytes. Okay. To last page. Well, to see if he actually is there, I'm gonna create a query. So select or limit like 5 records. Okay, that looks legit to me. And we can do, maybe we see user type. Select user type. Select user type from I've got it like rapid new line. Okay. Where user type equals subscriber limit 10. Oh no, it's not right. I should like select all. User type or subscriber. Yep, it's working. So now new tab and we go to Google Data Studio. Here we create new blank report. Data source, choose BigQuery. So in my first project in SC6601, we choose TV trips, add. Data report editors can create charts using the new data sources and can add dimensions and metrics not currently included in a report. Okay. Add to report. So click to Doxima. Okay. So I'm gonna rename this one first. So problem 1. Big data analytics. Okay. So the requirements is number of users by type, number of trips for top 10 stations. Okay. So for number of users by type, remove the data range dimension, and the dimension should be replaced by data type. And the record count is actually the total number of users per the type. So we're gonna rename it. Number of users per user type. Okay, so reformatting this table, make it small. Okay, so number of trips for top 10 stations. Okay, you can copy this and paste here. Just by talking about like top 10 stations, I think we have to add like two dimensions, because the starting station and the stop station are not always the same. So from station name, you can just replace this one and to station name. Top 10, we just show 10. Alright. So top 10 stations, we're gonna modify this. We'll see number of trips per station, per stations. Yeah. Make it a little bigger. Okay, so from this table we can say Lakeshore, M, Monroe Street. Oh wait, it appears like twice. So here I have to like edit. I have to edit this. Same value. Okay, how are we gonna modify this is dimension. We cannot I'll come here. So I'll probably like try like custom dimension. So say no select count count to count. Delete this one here. Add metric. So duplicate data. Add the filter. Include select field from station name. Select the condition. No, here. Filtering. Optional metric slices. Paste special. What if we remove one? Okay, that works. So different. Unique. Cross filtering. Yes. Drip down. Metric right here. I've got 6. Two station times. Count distance. Yes. Alright, so it's the same, means we can abandon this one. Yeah, so by removing that, we can get the top 10 stations where people get on the uses that they do the trips. Alright. So what about the 2 stations? Or can we try like blend these two together? Okay, blend. Add a table. No, not this one. Discard. I think there's a blend option for us. Well, it doesn't. So I'll probably like add resource, manage blends, add a blend. So table 1 from station name, record count, join another table. Join the table DB trips to station name. And a metric. Okay, so we're gonna join these two tables. Configure join. Where we wanna return this one. So full outer, save. See if we can use it just in here. So this is for table 1 and this is for table 2. Okay, so it's null value. Millennium Park, Michigan Avenue, Street, Lakeshore. Okay, so okay, forget about the blends. Remove it. So just by comparing these two tables, we can say the station names are all the same for the top 10 stations, just like different numbers. So I'm gonna keep this one, and say I'm gonna rename this to from stations. Okay, I need to rename it. So it's top 10. And then we need the line chart of usage by month, continuous all months. First day of the data until the last day of the data monthly, number of trips. Okay, so we're gonna add the chart and line chart. Just make it bigger. Okay, so yeah, the data range dimension, we'll put the here stop time and I'll put start. Yeah, start time as dimension first, but like don't sort it with it. Don't sort by this. I'm gonna say number of trips. Okay. Number of trips and change the color. Okay. So for the because we want to get usage by months, so we use the start time. But here we have to change it because we want to show like monthly. So we do like year, months. Then we do ascending. But don't sort by that. We're gonna sort by this one. All right. So the starting months actually is 2013. Good. Okay. By months. Do I have to do that? Daytime trunk. Nope, I'll keep it here. So page, new page. Edit a name first. Page, manage pages. So rename this Q1. Q1 of problem. And this is Q2 of problem 2. Okay. So now we move to page 2. Our number of trips. Am I showing this? No, this will be too hard to look at, so I don't show data tables. I can probably show some points. So each point is a new month. So starting with the first day of the data to the last day by month. Yep. Now go to the second page. Bike usage analysis. So a line chart of usage per hour. Now, since we have the date and time in the start time, we're gonna drag it here. Okay, replace it. Well, if it's not showing, we're gonna delete it. We do edit chart here. Okay, so we modify from here. 24 hours per hour. 24 hours numbers of trips. Okay, so we drop start time as dimension, and drop stop time as range dimension, and we sort by start time. Yep. And then reposition it to here. So the metric is not right for sure. We have to edit this. We want to see hour, so we do hour. And we can see like, wait, nah. We can see like per, we just got that. Yeah, we got it. We can see the usage of per hour, so change this, rename it. number of trips. 2 million? Okay. Alright, so the first one's done. Okay, like add labels. Oh yeah, this one with labels is actually good. Okay. More clear. Yeah, we move to the next one. A line chart of usage per weekday. Okay. Okay, of usage per weekday. Add a text field. Okay, per weekday. We can actually just like copy this one and like before that I want to do like I want to create a table. So this table helps me to identify if I'm doing the correct thing. So I actually need start time here, yeah, no problem, and stop time here, sort by start time. We'll modify that later. Delete. Oh no, we don't use this because we want to show like every 7 days, so we do it customize field. We still like weekly dates. Here we do date, time, trunk, and we select start time as the wait what start time as the argument, and the parameters should be ISO week. So this automatically defines start time every 7 days. We can see if it works. So we apply first, and here we're gonna change it to date, and sort by the same dimension, do ascending. Yeah, now we can see here the record count is actually for every single day. So this is for July 1 and this is for July 8. It's not accumulated. So what we're gonna do here is we add another metric, but we use the same metric, but like give it a different value with giving it a running sum. So running sum is accumulated one to the certain date. Okay, yeah, looks perfect. Probably like too big. Well, make it smaller. Make it small. Make it small. Okay. All right, this is good. This is better. So July 24, June 24 to July 1, yes, 7 days. July 1 to 8, yes, 7 days. So no problem. And the count, no, sorry, I should change the name. The count, wait, revoke. Okay, change the name. So number of trips per day. Not per day, right? For the day. number of trips for the day, and this one should be cumulative. Wait, how do I spell that? Cumulated. Okay. Cumulated number of trips. Good. Actually, can we wrap this? Nope. We just select number of trips to make it shorter. And this one is number of trips per weekly. Okay. So on June 24, it's 4,000. On July 1, it's 14K. So 4,000 plus 14K. Yeah, 18K, no problem. Actually, just for our easy understanding and no problem, I can just remove it in the chart. So a line chart of usage, 7 days. I'll do the line chart. So now I'll probably move this table here. So copy and paste, drag it here as chart. We do line chart. All right, so in the line chart, we should move the number of trips. This is just for our understanding. And we sort by date. Yes. And yet, something is still not right here. The center. This one got no problem. Can I drop it here? Something is not right about this one. I think it's gonna add. Alright, this is totally not right. I'm gonna delete it and I'm gonna start from the beginning. So we do yeah. On a such a scoreboard. So I will drop the start time here. Oh no, it happened again. I shouldn't do this because the data is too big. I shouldn't drag it. Let's wait for it to load. Alright, it's loaded. Maximize this a little bit. And yes, we got it. Wait, where's the sort? Where's the sorting? Cross filtering? No, thank you. Turn it off. Start time. Okay. We do this. Weekly dates. Weekly date. So date time trunk. Start time. ISO week. We have to apply it before we can change the type. So change the date. Replace it. This is not a line chart, sorry. Give it back to line chart. Okay, so should be ascending. So we start from the beginning. Here we can do what we can do. We do running number, running sum, or running count. Wow, it keeps go up for sure. Let's say per weekday, usage per weekday. Also, we don't show this. So we don't show this. So we only show number of trips. So we can just remove the running sum. The data, the chart is actually too big to show here, but like under here, we should generate from this table since we have it. Again, line chart, and we remove per weekly because it's gonna increase forever. Not forever, but like it's gonna increase for a while for sure. So we're gonna drag it like this. Move this a little bit. So ascending. Plan data, no, thank you. Okay. So let me maximize this. So if I show like points of this chart, so every point, every 2 points, the duration between every 2 points is 7 days. 22. There's these two. 13 to 20. So 7 days, yeah. And change the, wow, it's too bright. That's okay. Just like cancel the darts. Okay. View. Well, it looks pretty weird since we don't have a title. So I have an idea. So edit. You come here and you come here. You stay here. You come down again. Yeah. So we're gonna add text here. So bike usage analysis. Make it bold. Make it big. 44. Oh, that's, well, that's big enough to me. Okay. Copy. And we're gonna drag this down, drag this down, drag this down. Here in the name should be the dashboard. Okay, overall. Oh, overview. Yeah, overview. We're gonna finish off DV trips. Maybe I should just like wrap it. Put it in the middle. Oh, this looks much better. Okay, overview of DV trips. Okay, so we want to go back to this chart to see if I can do data labels. What is this for? No idea. Okay. So each dot is a mouse. Yeah, just leave it like this. No, this looks too bad. It's too crowded. Turn off the data labels. And this one looks fine. This one's okay. So every 7 days, June 24, make sure it's Sunday. Because ISO week actually starts with Sunday, June 24, 2013 date. What? It's Monday. No, it's not right. What about June 1? Maybe I should can I like modify this too? Let's just week. June 23. Yeah, it's Sunday. And this one should be June 30. Sunday again, so it's Sunday to Saturday. Wait, -1. No, not gonna work. I'm gonna just like leave it like this. Week. Okay. Like, is it working if we do let's say I'm gonna copy this. So daytime sub start time interval 7 day. Is it working? This was not working, but so we're gonna stick to this one. I changed the week here because ISO week actually starts on Monday, but like the requirement says it start first day starts on Sunday. So with the week here. Alright, looks good. Write some analysis. Okay, color should be don't be too bright. This one. Just use white. Okay. 16. So findings. Finding. So one during a day of 24 hours, 3 a.m. Not 3 a.m. Sorry, it's 5 p.m. 5 p.m. is the time that has the largest number of trips. And 8 a.m. is the time that has no, I should specify this. Number of trips in the afternoon time. Yeah, 8 a.m. is the time that has the largest number of trips in the morning time. Since 5 p.m. is the time for getting off work, and 8 a.m. is the time for going to work. But overall, people tend to have more trips using TV in the afternoon time than in the morning time too. July 19, September 1, August 18. Well, I gotta change this because there are more records than just 100. Modify to 500. Yeah, the total records is 341, so times 7 days is 2,300 something. Never mind. September 1. September 1 is Sunday. July 19, 2015, July 19. What are these dates? January 5, 2014. Sunday, number of trips. Life cycle of product. Well, I think, yeah, during, it's not about a week, it's about the season. So January and February, right? Jan, Feb, March. So summer, autumn, so spring and, all right. Based on the weekly chart of TV trips, it is found that during during winter and spring, weekday, Sunday to Saturday, shows 7 days. Okay, during winter and spring, people tend to use less TV for trips, but during summer and autumn, people tend to have higher frequency of using TV for trips than in spring and not spring and winter. Alright, this is it. This is for problem 1. I'm gonna stop the video right now. Okay, Alt Z.